more time ago. Like, how many years? 1 week, huh? Okay, so we started a chapter of calculation of level of service and capacity. Okay, and fortunately, because of the rain, I had to record that lecture for this section, and then I shared the link as well. So even after the lecture, you can go and check it out. And but I will quickly recap what we discussed. First of all, we said that we are only going to do the analysis, the level of service analysis for uninterrupted flow facilities. Okay, and the uninterrupted flow facilities are mainly three, which we are going to discuss. One is the basic freeways, the other one is multi-lane highways, and the third one is two-lane highways. Okay, then we moved on to the introduction of highway capacity manual, okay, which we are going to follow for these calculations, and this is also followed by your textbook as well. This manual gives us a complete definition of capacity, and according to them, capacity can be in vehicles per hour, or it can be in passengers per hour or people per hour if you are talking about a facility which is non-traffic, non-vehicular, pedestrian crossing, bicycle lanes, something like this. And capacity is under certain set of conditions. When these conditions change, capacity should be recalculated. What are these conditions which affect capacity? They are the design of the road and the traffic conditions, the environment, and the last one is the control conditions on the road. Okay, what type of control device we are using. Then these are the values of capacity under ideal conditions, which are again given for the three uninterrupted flow facilities. Okay, and you can see with the units, if you look at the units of capacity, you will see one of the ideal conditions, which is PC per hour per lane. PC is passenger cars per hour per lane. Okay, so in terms of traffic, the ideal condition is what? That all vehicles should be what? What did I say? PC is what? So all vehicles should be passenger cars. Okay, this is ideal condition for traffic, and we will later on discuss other ideal conditions as well. Then we moved on to the discussion of level of service. Okay, so first of all we discuss why do we need level of service. So up till now we know extreme conditions in traffic. We know free flow, we know traffic jam, okay, and we know capacity. But these are extreme conditions. They cannot be used for design. If you are designing for any of these extreme conditions, either you are overestimating your design or your design is useless. Design for free flow, it is useless. Design for traffic jam, design for free flow, it is overestimating. Okay, highway should not be at free flow in peak hours. Okay, so it's overestimation. And if you are designing for traffic jam, it's useless. It's like designing building to fall. Okay, the last design in your life, and you will be fired. Okay, so we need to define something between these extreme conditions, some levels between these extreme conditions for which we can design the highway, and these levels are levels of service. Okay, and they were given or introduced in the Highway Capacity Manual of 1965. Okay, it was not used, this concept was not used before. Okay, and now we will move on to the official definition of level of service. As I already mentioned, this concept was given in the Highway Capacity Manual of 1965. So the first definition came in 1965. Then they revised it a little bit in 2000. Okay, the other edition of the manual, and this is like a combined definition from both of them. So the main idea is given in the first statement that level of service denotes operating conditions for a lane or roadway under given volume. Okay, so if the volume is this much, if the volume is this high, then what will be the condition of traffic on the road? This is what we call as level of service. The condition of traffic or the condition of traffic flow at a given volume. Okay. Now, condition means what? I said condition of traffic flow. What does it include? So it includes all these things. Okay. It includes speed and travel time. Okay. If a speed is higher, traffic condition is what? Good or bad? Good, right? Why are you guys thinking? Good. High speed is good. Okay. High speed is good. Okay. Freedom to maneuver. How easily you can change your lanes and directions. More freedom? Good or bad? Good. On the road. On the road. Not for you guys. Got it? Huh? I do the voting for 4 days and somebody comes up, no doctor, take the exam on Saturday. We all have fun. So freedom for you guys not good. On the road, good. Okay. Traffic interruptions. More interruptions. Good or bad? Bad, right? Okay. Comfort. Good, right? You sleep in the car. And convenience, they are related. Okay. So you get the idea. Okay. So a level of service is a combination of all these things. How is the speed on the road? How is the travel time? How much is the freedom? How many are the interruptions and so on. You combine all of them into one thing which is called as level of service. And these things change according to what? According to what? Got it? Now level of service is not a number, it's a qualitative measure. Okay, so it's in terms of comparison. Like I just did, good or bad. There's no number. Okay? Good, bad, worst. Okay? So it's in comparative terms. So it's not a value. The level of service is a code. It goes from A to F. Right? Everybody knows that. If it starts from A, it has to go to F, right? Huh? So the level of service is qualitative, meaning it's a code which starts from A to F. Okay, and this is like a one-line definition for each level of service. Later on, we will look into more details. But this is like a one-line definition for each level of service. Okay, so it goes from A to E, no F. Okay, no F on the slide, but there is an F. Okay, you don't see the F until you get it. Okay, so, but the reason is very clear. You see level of service E. What are they saying? Level of service E is what? Capacity. Now after capacity? Yeah. Okay, so we already know that. Okay, so after E we have F. F means traffic jam. Okay, so E is capacity. D, maximum sustainable flow. Now there's a problem. We said capacity is what? Maximum flow, right? Now they are saying E is capacity and D is maximum flow. What is this? They're not my students. That's right. Yeah. Yeah. The answer is in the term which they added, maximum sustainable flow. Capacity is maximum flow, yes. Capacity is maximum flow, no doubt about it. But that flow does not remain sustainable. It does not continue. It does not happen continuously. Okay, when you are in capacity condition, capacity means what? It's completely full. So people are moving, But it's so full, but they cannot move continuously. They have to stop and start again and again. Okay, so capacity is maximum flow, but it's not maximum sustainable flow. In order to maintain the flow continuously, I need some gap. I need to be below capacity. Get my point? In order to make sure the flow remains continuous, I need some gaps as well. Okay, if there are no gaps, that means the flow cannot remain continuous. Got it? Yeah? Okay, so capacity is maximum flow, but at that level the flow does not remain sustainable. Okay, then C and B, practical capacity for urban and rural facilities. I'll come back to it. And A is free flow, the best conditions. Okay, highest speed, maximum comfort, maximum convenience, least interruption, least travel time, so on and so forth. Okay, so all the parameters we define, they are best at A. Okay, now what do we mean by practical capacity? When the flow on the highway goes from A to B, usually the speed does not start to decrease for some time. Okay, in lecture 1 I showed you the graph between speed and flow. Okay, so this was the graph for which we drive the equation between speed and flow. Flow equals something into s minus something into s square, something like this. Okay, so this was the graph for which you drive the equation. Okay, and then I showed you another graph which I will show you later on as well in this chapter, which was something like this: straight line, dip, further dip, and then a curve. Okay, so this is for the purpose of having the equation. This is more practical. Okay, now you see what is happening here. Flow increases, speed constant. Okay, now this is the point they are talking about, practical capacity. Practical capacity is here. There's another name which I will show you later on. But practical capacity is the point after which the flow increases so high that now drivers start to decrease their speeds. Up till this value, the flow was increasing, but the drivers were still comfortable to go at very high speed. From this value onwards, now that they are now very close to each other, so now they are responding to each other. So the speed is going down very quickly. Okay, you see, flow increase this much, speed decrease this much. Okay, so this point is what we call as practical capacity, and the point where the speed starts to go down quickly. Okay, now I told you level of service is qualitative, right? So it has A and B and C, right? Okay, you guys also have A and B and C, right? Huh? But somehow I have to come up with a number to assign you A and B and C, right? I need to have a value on the basis of which I will say, okay, this is A, this is B and C, right? Okay, so the value which is used for finding out the level of service is called as service measure. So if somebody asks you for level of service, yes, the answer will be A or B or C, but that A or B or C has a value behind it. So I am saying this is A because this value is this much. Okay, so the value which is used for calculating level of service or for finding out level of service, that value or parameter is known as service measure. Alright, so you cannot randomly assign A and B and C to highways. I can do it for students, no problem. You can look at your face and tell, but not for highway. Okay, now service measures depend upon the type of facility. Now we are doing which type of facility? In this chapter, we are doing which type of highways? Uninterrupted. Okay, so these are the uninterrupted highways. We are doing this case. Okay, in these cases you can see the level of service depends upon density. Okay, freeways, mountain highways, the level of service depends upon density. Somebody asks you for level of service, you need to calculate density. Except two-lane highways. For two-lane highways, it depends upon speed. We know speed, right? It depends upon time spent following, which we will discuss in the next chapter. So two-lane highways, we will do it in the next chapter. Okay, I will explain these two parameters. But most of the uninterrupted flow facilities, their level of service can be found using density. For two-lane highways, speed and time. Okay. For interrupted flow facilities. Now, interrupted means what? Interrupted means what? Intersections. Any type of intersection. Okay. So for intersections, the service measure is control delay. Okay. We already talked about it. You don't remember, but we did. Okay. For any type of intersection, somebody asks you for level of service, you will calculate what? Control delay. Got it? Then service measure for non-traffic facilities, bicycle lanes, bus systems, pedestrian crossings, sidewalks. For these, obviously now you cannot use traffic parameters. Density, speed, travel time. These are all what? Related to traffic. I'm doing it for a facility which does not have traffic. Okay. In that case, then we ask the users their opinion. So it is based upon opinion. Okay. So you go there and you say, okay, if A is the best and F is the worst, what do you think about this facility? Will you give it an A or B or C? What? Got it? So for uninterrupted flow, mainly density. For two-lane highways, we use speed and time. For interrupted flow facilities, we use what? Control. For non-traffic systems, we use what? Questions. We asked them. Okay, single question, no problem with that. Okay. Okay, we said level of service gives you the traffic conditions under what? A given volume. Okay. Now if I give you volume, can you convert it to flow rate? Can we convert volume to flow rate? How?
Divided by the time you counted the volume.
Okay, anybody else? There's a factor for it. Which factor? You know that. Which factor? pH. Okay. When you get this, I knew it would. You know. Okay. Peak hour factor. Peak hour factor is the ratio of volume and flow rate. Right? Peak hour factor is the ratio of volume and flow rate. Okay. So when I say level of service has a volume, that means volume can be converted to flow rate. So whether I say volume or flow rate is the same. The change is what? Just a multiplication with the factor, right? Okay. So, and normally for calculations we use flow rate, we don't use volume. Capacity is maximum flow rate. The equations which we had, those were for flow rate. Equation with the speed and density, those were also for flow rate. So level of service also depends upon flow rate. They call it volume because volume can be converted to flow rate, no problem. Okay. So every level of service has a range of flow rate. Okay. If you are out of that range, that means the level of service has changed. For example, level of service A has a range of 0 to 400. Okay. That means what? If the flow rate is 0, level of service is A. If the flow rate is 100, level of service is still flow rate is 300, level of service still A. Till you are in this range, your level of service is same. Okay. When you go out of the range means what? You cross the maximum, right? You have crossed the maximum. So then the level of service will change. Like I can give the example. If the range is from 0 to 400, when you cross 400, you are going from A to B. Now let's say B has a range up to 900. Okay. So when you cross 900, you will go from B to C, and so on. These maximum values of each range are known as service flow rate. Okay, so service flow rate is the maximum flow rate for any level of service. When you cross that value, level of service has changed. Clear or not? Hussain? Clear? Okay. So every level of service has a maximum flow rate. When you cross that value, the level of service changes. That maximum value is known as service flow rate. Okay. So you can see we have service flow rate for A, we have for B and C and D and E. And what did I say about E? E represents which condition? Capacity. So the maximum service flow rate or the service flow rate for E is capacity. Okay. And after E I will have F, jam. Okay. Is there a maximum service flow rate for F? No, because it doesn't change. It's F, it's an F. Okay. F doesn't change. Okay. And this is the thing which I started with. If you have flow rate, you can convert it to volume by peak hour factor. Okay. In this chapter, we will discuss two types of uninterrupted flow facilities: basic freeways and multi-highways. Basic freeways and multi-highways. Okay. What are basic freeways? Basic freeways are those highways which do not have any intersections. So they are pure uninterrupted flow facilities. Okay. But even basic freeways have ramps. Basic freeways can have ramps. Another name for ramps is an interchange. Okay, so interchange or ramp, same thing. Okay, so you can enter the freeway from a ramp and you can exit the freeway from a ramp. There is no intersection for you. Okay. But why we do not consider ramp as an intersection or as an interruption? It is because of the priority, the preference. When you are entering from the ramp, who has the priority? You are the guy on the freeway. On the freeway. When you are exiting, who has the priority? The freeway has the priority. Okay? The person on the freeway always has the priority. That's why we do not consider ramps as interruptions. Okay? You are on the ramp, you have to wait. That's it. Okay? There is no other way. You are exiting, again, they have to provide some space for you so you don't block the freeway while you are trying to exit. Okay? In any case, for the ramp, the freeway flow should not be interrupted. Got it? So that's why freeways have ramps, but ramps are not considered as interruptions. Okay? And freeways are classified or defined by the number of lanes they have. So we can have 4-lane freeway, 6-lane freeway, 8-lane freeway, and so on. Okay? And I told you earlier as well, when we say the number of lanes, it is for both directions. So when I say 4-lane freeway, it's 2 plus 2. 6-lane freeway, 3 plus 3. 5-lane freeway, 2.5, 2.5. Huh? Okay. We have, okay? Yeah. Not by the ministry. We made it 5. We make it 5. Make our own 5 lanes. Okay? Then we have multi-lane highways. Multi-lane highways have intersections, but the intersections are very far from each other. So we still consider them as uninterrupted. Even with the intersections, we consider them uninterrupted because the intersections are so far from each other that there is a very big part of the highway where the intersection has no effect. Cars are moving as they move on freeways. Okay? And they have given us a limit that the spacing between the intersection should be more than 2 miles. Okay? So multi-lane highways are those highways which have intersections with a spacing of more than 2 miles. Okay? Multi-lane highways can again be defined on the basis of number of lanes they have. So you can have 4-lane multi-lane highway, 6-lane multi-lane highway, 8-lane, and so on and so forth, like we did for freeway. Another classification for multi-lane highways is on the basis of the median. Multi-lane highways can be with median, without median. Okay, so if they are with median, we call them divided. If they are without median, we call them undivided. Okay, so if I say 4-lane undivided highway, that means 2 plus 2 without median. Okay, if I say 6-lane divided highway, that means 3 plus 3 with median. Clear? This is only for multi-lane highways, not for freeways. You cannot have divided freeway and undivided freeway. Freeways are always what? Divided. Freeways are always divided. You cannot have undivided freeways. Okay, because of the flow and so on. Okay, like I told you, in this chapter we will discuss freeways and multi-lane highways. Why? Because the procedure is same. The procedure to calculate level of service and capacity for multi-lane highways and freeways is same. So we'll discuss them together. Okay. In both cases, the first thing you need is the free flow speed. Whether you are doing it for freeways or multi-lane highways, the first thing you need is the free flow speed. What type of study we do to find out the free flow speed? Which study do we do to find out the free flow speed? Huh? We did it for your project. Huh? Yeah, spot speed study. Okay, spot speed study. Okay, and you can see here the same condition which I mentioned for spot speed, that the flow should be less than 1000 vehicles per hour. So less than 1000 vehicles per hour per lane is considered as free flow. So you do a spot speed study, you can find out the free flow speed. The first thing you need is the free flow speed. The next thing you need is the speed flow curve. This curve. Okay, so you need two things to find out the level of service or capacity of multi-lane highways or freeways. The first thing is free flow speed. The second thing is the speed flow curve. Okay. The base conditions, meaning ideal conditions. The base or the ideal conditions for these highways is no heavy vehicles. So all vehicles are what? I also mentioned it earlier. All vehicles are what? Passenger cars. Okay. And all drivers are familiar users of the facility. All drivers are familiar with the highway. Okay. They know where is the turn, where is the signal, where is the hump, where is the camera, and so on. Okay, they know which lane to be and so on. Okay. So they know where the highway is going, and they know where they are going. Okay, this is more important, right? The highway goes to the same spot every time. If you don't know where you are going, problem, right? Okay, so if the drivers are not familiar, what will happen? Okay, first start with this one. What happens if you don't have all vehicles as passenger cars? What will happen? If there are trucks and buses, what will happen then?
That's the speed. Slower.
They are going slowly and
Form a queue.
they form a queue. And what else?
It's not free.
It's not free flow. Okay. Anything else? So the trucks and buses, they go slowly. They will affect other vehicles, and they also do what? They also take up a lot of space, right? One truck or one bus may take up a space of 2 or 3 cars. Okay, so this is not ideal, right? 10 trucks may take up a space of 22 cars. Okay, less flow, right? If you count number of vehicles, less. Okay, so that's why all passenger cars is good, because cars go faster, they take less space, the acceleration is good, and so on and so forth. Okay, what about drivers? If you have unfamiliar drivers, what happens then?
They will slow down
Why?
because they don't know the road.
They don't know the road, so they will slow down, and they will also do what? Huh? Who cares? More traffic there, okay. What else?
They will
While they are driving, what else they do? A lot.
Change lanes.
Changing lane. They see GPS, so they don't go to wrong destination. Okay. So again, changing lanes and slowing down, not good for the flow. So that's why familiar drivers are good, unfamiliar drivers are not good. So that's why we call them base conditions or ideal conditions, because these conditions will produce maximum flow. Okay. Now this is more details about each level of service. I already gave you one line definition, right? This is more more detailed notes for each level of service. So level of service A, you have free flow conditions. The flow is very low, so free flow conditions, you are going at very high speed. And you have, the flow is so less that you are not looking for other drivers. You are not affected by other drivers because they are very far from you. Okay, so your speed is very high, other drivers are very far from you, there are lots of gaps available for you. So whenever you want to change your lane or change your direction, you can do it without any problem. Okay, so lot of freedom to maneuver, comfort level is high, speed is very high, no interruption, lot of gap, and so on. In this condition, for example, if you have 3 lanes, one of the lanes is blocked. One of the lane is blocked because of any reason. What you will do? What you will do? You will not even think of half a second. And here you are thinking for 5 seconds. Like, yeah, you will go do what? You will go to the other lane, right? Okay. Why? Because there is a gap available. Like I told you, the drivers are very far from each other. So if you wish to change your lane, you can do it without any problem. The other lane is also almost empty. Okay. The spacing in this case goes up to 480 feet. Okay. Average spacing between 2 cars. Okay. Then we have level of service B. Level of service B, obviously the flow is higher than A, right? The flow is higher than A. Okay. So I told you, right? Each level of service has a maximum flow rate. So you already crossed the maximum of A. And level of service B. B is still free flow. So you're still going at high speed. You still have gaps available. Okay. But now the flow has become higher, so the gaps are slightly narrower. Okay, smaller. Okay. So that means that, okay, I'm going at high speed, but I will be more careful now. Okay, the other drivers are closer to me than the previous case. So, okay, I see there's a lot of gap, but I will be more careful. Okay, so I told you that the factors for traffic flow, you have speed, so speed is very high. But the other factors, freedom to maneuver, comfort, convenience, they are now slightly lower. Okay, so now you have to be more careful because the flow is slightly higher. The spacing in this case can go up to 293 feet, but even in this case, if there's a problem in one of the lanes, you can easily go to the other lane because the gaps are available, lot of gaps available for you. Level of service C is still free flow. Okay, so your speed is still very high. Okay, but again the flow is now higher than B, right? The flow is now higher than even B. So you can go at very high speed, but since the gaps have reduced now, so your freedom is even lower. Freedom to change your lane, freedom to change your direction is even lower. So it may happen that you decide to change your lane, but at that time there is no gap for you. Okay? So what do we do then?
Reduce speed.
Reduce the speed. Very good. Okay? We should have more people like you in the traffic. Right? Usually it's the other way around, right? There's a gap there after 2 kilometers. I can go there in 2 seconds. Okay? But the point is, gaps are not readily available now. I have to adjust myself to find the gap. Okay? And in this case, obviously, if you want to change your lane, there's a problem with your lane, you want to change it, but there is no gap, then you have to stop. When you stop, people behind you stop, hopefully. Okay? The spacing in this case goes up to 200 feet. Then we have level of service D. Okay? The level of service D is after this now. So the gaps are less, not only for changing the lane, the gaps are less even for driving at high speed. The other driver is very close to you now. Okay? So now you are selecting your speed based upon the other driver. Okay? We are now slowing down. So it's not only about the gap, it's also about your speed. The speed is slowing down now. Okay? So obviously, if the gap is less, that means changing lanes and changing direction is not at all easy. Okay? And in this case, if you have a problem in one of the lanes, it can affect the other lanes. Okay? Average spacing in this case goes up to 151 feet. Average spacing between the cars goes up to 151 feet. Then we have level of service E. Level of service E was what? Level of service E was capacity. Okay, now capacity means what? If something is at capacity, that means that thing is full. So gaps? No gap. Okay? So in this case, obviously your speed is very low. Your speed is very low. Okay? And since there are no gaps, no usable gaps. No usable gaps. So even if somebody wants to change a lane, now in the previous case what we were saying, okay, you want to change your lane, you may find a gap, you may not find a gap, you may have to wait for the gap. In this case, there is no chance. You are already at capacity. Keep on waiting, there is no gap. So what do we do? I want to change my lane. There is no gap. So what do we do?
I can.
Huh?
I can.
You cannot? So how do we reach here? Huh? What do we do if there is no gap? Then you.
Where's my siren?
Stop the car.
Okay. You get the point, huh? You get the point. Okay. The other has to be aware of you and he has to stop for you. Simple. There is no gap. Okay. So waiting will not happen. Okay. So the other driver has to stop for you. So now changing lane is routine, right? It happens very often in any condition. So even the routine maneuver will cause the traffic to stop in this case. Okay, and the average spacing goes up to 170 feet. Now, what is spacing? Spacing is gap, right? What did we say about gaps? There are no gaps. So what is this 117 feet?
This is the spacing from one point to the other.
Okay, and it's not a gap. The gap is not included in this. So between one car and the other car, I have a spacing of 117 feet. So why I'm saying there's no gap?
Most of it is the length of the car.
Length of the car, most of it not even close. Length of the car is 20 feet. That's it. So 117 feet. I can fit easily 5 cars. Right? Okay, so why are we saying there's no gap and the other driver has to stop for you if you want to enter the other lane? Enter this 117 feet. What's the problem?
This is the safe distance that the driver will take between the...
Yeah, the safety is an issue because the cars are moving, remember. Yeah, we are not talking about parking the car. If you are talking about parking the car and you have a distance of 100 feet or 117 feet, you can easily park, like I said, 5 cars in this. And each one will have a distance of 4 or 5 feet between them. There is no problem with that. Okay, parking is not a problem. But to enter between 2 vehicles, 117 feet is not enough. You get my point? That's why I said there are no usable gaps in this case. No usable gap. 117 feet is there, obviously. Some gap will be there, right? 2 cars are moving, there will be some gap. If they are moving, there will be some gap. But is it enough for a third car to enter at this much speed? Okay, remember the speed is still very high. We are talking about freeways and multi-lane highways. These highways have a design speed or a speed limit of 100 and 120. So even at capacity, they are going at 50-60 kilometers per hour. To enter between 2 moving cars which are going at 50-60 kilometers per hour, and you are doing it as well, okay, this is not safe. Okay, you must be thinking in your heart, what is he talking about? Anyways, yeah, it's not safe. Okay. So we said we need free flow speed and then we need the speed flow curve. Okay, so this is the curve I was talking about: flow on the x-axis, speed on the y-axis. Okay, and I already showed you what happens on this curve. The first part is what? The flow is increasing, but the speed is constant. And how much is it? Free flow speed. Second part, when the speed starts to go down, the level of service C or D. Okay, and then it keeps on going down until you reach what? Capacity. Okay, now the curve is ending at capacity. Why? Why there is no curve after capacity? The cars are stopping now. Okay, so that's why. Okay, this point I called it practical capacity earlier. In this curve they are calling it break point. Means the same thing. The point after which the speed quickly goes down with the flow. Clear? Now, to draw the curve, I need an equation, right? I need an equation. For which part I need the equation? The curve part. This part is not a curve, it's a line. So this line has a value of free flow speed. That part between breakpoint and capacity is a curve. And this curve has this equation. Okay? This is the equation of the curve part only. Okay? So FFS, free flow speed, we know. C is capacity. C is what? Capacity. DC is critical density. What do we mean by critical density?
When it's changed from... it's the point where we reach the capacity.
Yes. Okay, the point where you reach the capacity. or in critical density. Okay, so the value of critical density according to highway capacity manual is fixed, which is 45. So they are saying when you reach a density of 45, you have reached capacity. Okay, so DC is 45 fixed, VP is any flow rate. The flow rate will change, the speed will change, right? So VP is any flow rate and BP is breakpoint, this value. Okay, so free flow speed, capacity, critical density, which is 45, BP changes and BP is breakpoint. Clear? Any questions?
What is A?
Huh? A is a constant. I wish this in the next slide. It's given in the next slide. Okay, so A is a constant. Okay?
Doctor, I have a midterm in 10 minutes. Can I go to it now?
Yes. We are all going.